Hey, welcome to CNC Router Project Start to Finish. In this episode, we'll be looking at all the steps involved in the creation of this portrait orientation mailbox. For the main body of the box, I ended up using 12mm Baltic birch plywood, specifically two pieces that each measured 12 inches wide by 30 inches long. The only other wood involved in this project was some 1/4 inch thick poplar, which was used for the Art Deco style inlaid lettering. In addition to the wood, 16th inch thick galvanized lumber strap ties were used to form the magazine hooks extending from the bottom of the box. Finally, there's a pair of exposed 1-inch narrow utility hinges that attach the lid to the back of the box. Although this is a portrait orientation unit, the same basic concepts could be applied to make a landscape orientation mailbox or some basic general purpose box. Like any standard box, this one consists of a front, a back, two sides, a top, and a bottom. The front and back pieces of this project require machining on both sides. I'm going to start by looking at the back piece, specifically the front face of the back piece. The basic shape is just a rectangle with a rounded top. This was created by drawing a rectangle, extending an arc from the upper corners, and removing the top horizontal line with the vector trim tool. Next, there are two keyhole shapes that will ultimately be used to hang the box. These were drawn using a keyhole toolpath gadget, but an alternative is to weld together a 3/8 inch diameter circle and a 1/4 inch by 1/2 inch rectangle with 1/8 inch radius corners. I'm going to run a pocketing toolpath on these keyholes, cutting through the full thickness of the material using a 1/4 inch downcut bit. The last feature on the front face of this piece is this rectangle located 1/4 inch off the bottom edge. This represents a groove into which the bottom of the box is going to fit. For it to fit properly, the height of this rectangle needs to be equal to or slightly greater than the thickness of the material. To get an accurate measurement of the material, I like to take samples of it in several locations using digital calipers. In terms of toolpathing, this rectangle gets pocketed to a depth of 1/8 of an inch using a 1/4 inch downcut. At this point, it's time to flip the material over so that the back face of the piece can be machined. To ensure the material is properly positioned during this process, I'm going to use a system of 3/8 inch diameter dowel holes and pins. The two circles that were just added represent dowel holes that need to be created in both the material and the spoil board. In both instances, I used a profile toolpath with a 1/4 inch bit, machining to the inside of the vectors, and with a spiral ramp. For the depth of cut, I went through the full thickness of the material and 3/8 of an inch into the spoil board. Now, when the material is flipped horizontally, dowel pins are driven through the holes in the material and align with the holes in the spoil board. This flipping process needs to be simulated in the software as well. To do that, I'm going to select all of the vectors, choose Mirror Selected Objects, and click on Flip Horizontal. The primary machining required on the back face of this piece is some pocketing to both locate and recess the magazine hooks. I've drawn two rectangles that are slightly wider than the lumber strap ties and pocketed to a depth equal to their 1/16 of an inch thickness. Finally, the back piece is cut out using a profile toolpath. I used a 1/4 inch upcut bit in this case in order to minimize damage to the front face. If an upcut isn't available, the piece can be flipped back over and profiled with a downcut. The sides of the box are in the form of a rectangle with a sloped top. To draw this, I created a rectangle and then used the polyline tool to pull a line segment from the upper left corner across the right side at an angle of 30 degrees. The vector trim tool was then used to remove the unwanted parts. The sides are going to meet with three other pieces of the box: the front, the bottom, and the back. Consequently, 3 joints are required. I'm going to take the same approach to joinery that was used previously and pocket out some grooves. Once again, these grooves need to be equal to or slightly larger than the thickness of the material. The front and bottom grooves are located a 1/4 of an inch from their associated edge. The groove that joins with the back piece, however, runs from the edge inward. Pocketing an area right up to the edge like this typically results in a small sliver of material remaining when the piece is finally profile cut. To prevent this, I'm going to enlarge the pocket so that it extends slightly beyond the edge. I'll select the rectangle and choose the Set Selected Object Size button. With the Link XY box deselected, I'm going to set the anchor to the lower right-hand corner to prevent that from moving. Then I'll increase the width by about 1/10 of an inch. Since the box requires two sides, with one being a mirror image of the other, I'm going to select the side along with the grooves and choose the Mirror command. With the Create Mirrored Copy box checked, I'll click the Flip Horizontal button and reposition the vectors so they'll fit on the piece of material. All of the grooves are pocketed to a depth of 1/8 of an inch using a 1/4 inch downcut. Finally, the side pieces are profiled using a 1/4 inch upcut bit. The front piece of the mailbox also requires double-sided machining. On the back face, the only work involved is creating and toolpathing a groove that receives the front edge of the bottom of the box. Once again, the groove is located a 1/4 of an inch from the edge and pocketed to a depth of 1/8 of an inch. The front face of the piece has two elements to deal with. First is the inlay for the text. Now I chose the painfully obvious, thoroughly uncreative route and spelled out the word mail. This could just as easily have been house numbers or an interesting design of some sort. In any case, I selected the inlay toolpath to create a female inlay pocket. The cut depth was 1/16 of an inch. The letters are on the small side, so I used an 1/8 inch bit. Finally, the pocket allowance was set to 1/64 of an inch, or 0.015. The other piece of machining necessary on the front face is some beveling. Remember that the tops of the side pieces were cut at a 30-degree angle, so in order for the top of the front piece to line up nicely with that, it needs to be beveled at the same 30-degree angle. To accomplish this, I'm going to run a couple of profile toolpaths using a 60-degree V-bit. I've drawn two straight-line vectors, one located directly on what is the edge of the piece, and a second slightly offset from that. The reason two profile toolpaths were needed is that the cutting edge length of the angled portion of the V-bit I used wasn't quite long enough to bevel the full thickness of the material in a single pass. So I created a second line to effectively move the bit over and machined it to a lesser depth to complete the bevel. To determine the values for the offset and depth using a 60-degree V-bit, I took the following approach. First, a 30, 60, 90 triangle was created using the rectangle, polyline, and vector trim tools. This was positioned with its lower left corner at a whole numbered point. A copy of the triangle was made and somewhat arbitrarily moved a 1/4 of an inch to the left. It was then nudged upward until the hypotenuses of the triangles were in alignment at the highest zoom level. The difference between the Y values of the two triangles is equal to the difference that there needs to be in the depth of cut of the two V-bit profiles, 0.433 inches. Applying this to the project then, the depth of cut on the outermost profile was set to the full thickness of the material, 0.465. The tool is set, obviously, to a 60-degree V-bit, and I have machine vectors set to on. For the profile that's offset by a 1/4 of an inch, the cut depth is set to 0.032, which was derived by subtracting 0.433 from the original depth of 0.465. The only remaining toolpath is just an outside profile of the piece using a 1/4 inch downcut. The bottom of the box is just a plain rectangle. Its width is the same as the width of the back piece, while its depth is equal to the distance between the front and back pieces plus the sum of the groove depths. Looking at the vectors of the sides, we can see the distance between the back and front piece is 3.32 inches. Adding an 1/8 of an inch for the depth of each groove on the front and back pieces gives us a 1/4 of an inch. Adding that to the previous figure, the depth of the bottom piece should be 3.57 inches. The only toolpathing involved here is just an outside profile. The lid of the mailbox also takes the form of a basic rectangle. I made it slightly wider than the assembled box by about an 1/8 of an inch per side. It also extends about a 1/2 inch beyond the front of the box. The rear edge of the lid requires a bevel, identical to the one that was made on the front piece. Toolpathing, therefore, is the same. The toolpath for the text is just a straight mail inlay insert. The cut depth is set to the full thickness of the material, and I use the same 1/8 inch bit that was used to create the female pocket. Since this piece required double-sided machining, I ran the toolpath for the dowel holes in the material. The holes in the spoil board were pre-existing. I ran the back face first in this instance, so the next step was to pocket for the magazine hooks. This was followed by a quick test fit. I then flipped the material horizontally, tapped in some dowel pins, and repositioned it. On the front face, I pocketed the keyholes, the groove for the bottom piece, and then performed the final profile cut. With all of the pieces sanded, a decision needs to be made whether to assemble the box first and then apply the finish, or to apply the finish and then assemble the box. I opted for the latter approach to help ensure easier, more thorough coverage of the finish. It does create more work though, and if I had to do it again, I'd consider trying the other option. With the finish first method, all areas of the wood receiving glue are masked off. I use blue painter's tape for this purpose. For the finish, I decided to apply spar urethane, 3 coats about 4 hours apart, with a very light sanding in between. After completely dry, I double-check the fit of all the pieces once again, as sometimes a buildup of finish can occur and cause interference. I decided to assemble the box in a face-down position. First, I placed a relatively narrow strip of 1/4-inch MDF under the front piece to account for the fact that it's recessed from the front edge of the side pieces by that same amount. Starting with the front and bottom pieces, I applied glue to both the grooves and the mating edges. Next, the 2 sides were added. And lastly, the back piece was put into position. I then used a number of padded trigger clamps to help ensure that good contact was maintained between the pieces while the glue was drying. For the magazine hooks, I ended up using a pair of lumber strap ties. These can be found, appropriately enough, in the lumber section of most big box hardware stores. They seem to come in two different thicknesses. I opted for the heavier of the two, which is about 1/16 of an inch thick. Being so lightweight, the strap ties bend pretty easily, but to help ensure smooth, uniform bend, I threw together a primitive bending jig. Two pieces of 2.5 inch diameter, 3/4 inch MDF were glued and screwed to some scrap sheet stock. I then screwed down a 2x4 about 1/16 of an inch from that. The material was then inserted between the two pieces and bent 180 degrees around the circular piece. With the two bent pieces clamped side by side, I marked a cut line approximately 2.5 inches from the bottom of the curve. Next, the pieces were cut to the outside of that line using an angle grinder with a cutting wheel. A flap disc was then used to remove any burrs and radius the corners. To install the magazine hooks, I clamped the box down to a flat surface and then clamped a block of wood 5 inches off of the bottom. The hooks were then placed in the grooves, butted up against the wood, and attached to the box with screws. Now it's time to attach the lid to the back of the box. I ended up using 1 inch wide, narrow utility hinges for this purpose. I decided to locate the hinges a 1/2 inch from the outside edge. Since the hinges are 1 inch wide, I set a combination square to 1.5 inches and marked the location of the inner edge of the hinge with a piece of painter's tape. To help ensure that the hinge joint doesn't bind, I created a gap between the two pieces by temporarily inserting a thin shim, in this case a hacksaw blade. With the lid centered and shimmed and the hinges in place, I drilled screw holes into the back piece with the aid of a self-centering hinge bit. With the hinges attached to the back piece, the process was repeated for the lid. Finally, the inlaid lettering was sprayed with Zinsser 123 primer, followed by Rust-Oleum hammered silver paint and some clear coat. To attach the letters, I used Loctite superglue, which was easy to apply and dried fast and clear. If you find these videos helpful and informative, and you happen to be in need of some of the tools or supplies used in these projects, please consider purchasing them from Amazon via the links on my associated website. Thanks.